Okay, so when we're in Unit 2, not a whole lot of difference than what we were doing in Unit 1, graphing a transformation or a transformed graph. But you have to know what you're actually changing about it, what you're actually trying to solve. So if you have an equation, your answer is just going to be for x, because that's all you start with, just an x. If you have a system of inequalities, there's no way to write your actual answer out. So I'm going to run through the Unit 2 stuff. I'm going to try not to go too fast, but I also want to get done in the next 20 minutes. Okay, so on solving a nonlinear equation by graphing, I have an absolute value function on this side with an HK of -4, -3. That's that double negative happening in here. So -4, -3. Normal absolute value would go out 1 and up 1 in both directions. Because this has an A of 2, it's going to go out 1 and up 2 in both directions. And it's important to graph precisely on problems like these because you are solving by graphing. I'm going to take my straight edge. And then I graph the other half, x plus 4 squared minus 6, so that's a parabola with a vertex, of -4, -6. So out 1 and up 1, there's no change in the stretch factor. Out 1 and up 3, and then out 1 and up 5. So right there, I'll go ahead and graph that. These 2 points right here are my points of intersection. So how do I write my actual answer? Do I write the XY points? You don't write Y because there's no Y to begin with, so I'm not going to put Y in my answer. So my answers are x equals -1 and x equals -7. So if you only start with x's, you only end with x's. If you start with x's and y's, your answers should be x's and y's. Let's jump to the second page. So we didn't go in straight order on this, but we'll jump around a little. So the nonlinear system, I have both x's and y's to begin with, so I'm going to have both x's and y's in my answer. So if I have 2 times x plus 4 squared minus 5, my parabola is going to be at -4, -5. Yeah. And instead of going out 1 and up 1, it's going to go out 1 and up 2. And instead of out 1 up 3, it's going to go out 1 and up 6. So that's my parabola. My absolute value, x plus 4, absolute value plus 1 is going to be at -4, +1. Sorry, what? Zoom in. Oh, I can't because we're going to run out of time. I'm sorry. But I am videoing this, so you can just look online. Sorry about that. So this one, the absolute value is going to go, it's a regular stretch factor, so out 1 and up 1 in both directions. So my points of intersection here, where the last one, I had an equation and I only wanted the x's, now I want both x and y. So these solutions are going to be the point -2, 3. And the point -6, 3. So I'm going to do some jumping around, so I apologize. On that same idea with solving with graphing, we're going to look at the inequalities. So let's go up to that upper right-hand corner of that same page. And we'll graph these 2 sides. So you need to be really comfortable with the graph transformations, that stuff from Unit 1. So that's a good place to focus. So the square root of x minus 4 plus 3, that's going to have an HK of 4, 3. That's a sideways parabola, but only 1/2 of it. So that up 1 over 3, or sorry, up 1 over 1, up 1 over 3, so that's your square root. And then the absolute value is x minus 6 plus 3, so that's going to be at 6, 3. Can somebody grab that for me? Okay, so what we're looking at in terms of our answer, this is saying that our square root graph is greater than our absolute value graph. So we're literally looking at where our square root graph is above our absolute value graph. And that would be, so this is our square root. Right now it's under our absolute. From here to here, it's above the absolute value graph. So the way that you're going to write that, and this is not an or equal to, so where it's equal, those are going to be open circle. That part doesn't matter as much. You need to just know the boundaries. Yeah.
Is it possible to put on
Is there going to be any shading at all?
Yeah, there will be some shading, but not until we get to systems. We'll do that one next. So the way that I'm actually going to write this is that my x goes from, so x is going to be between 5 and 8. So we know x is greater than 5 and less than 8, so that represents that part in the middle there. Okay, so I want to jump back, since we're on the inequalities, jump back to that last one on the first page. So on this one, we are shading. When you do a system of either equations or inequalities, you're going to be shading. So this one, y is greater than x plus 2 to the third plus 2. So my hk is negative 2, positive 2. And this is a cubic with no stretch factor, so I'm going out 1 and up 1 and out 1 and down 1. Sorry, I'm on the very last one on that first page. So I have my little swoop there, and then going up. So that's the graph of my cubic. I have to shade one side or the other. So if y is greater than, am I going to shade up or shade down? Up. So the way that you determine what side, I wouldn't worry about sides. I would worry about, if I put my pencil right here, anywhere on the graph, I'm going to shade up if it's greater than, or I'm going to shade down if it's less than. So if I look at this and I shade up, that means everything on this side of the cubic is being shaded. And then what should I do differently with that actual graph? It should be, yeah, it should be more accurate, but it should also be a dashed line. Right, because it's not an or equal to. Yeah. All right, and then x squared minus 5 is going to be a regular parabola with a vertex at 0, negative 5. This one's going to be solid line. And I'm going to shade up or down from there? Up or down? Down. Because y is less than, so I go to any point on my graph and shade down. So my solution region is everything over here where I'm shaded for both colors. And all I'm going to ask on your test is that that particular region is obvious, and if it's hard to tell, say this part is shaded and write it out. That's perfectly acceptable.